So I hope you have done the setup of OpenGL in your system. There is an assignment and you are supposed to run a program, okay, that will show that OpenGL is set up in your system. Okay, so there is a sample program and you are required to send me a screenshot that will show the code along with the output of your homework. Okay, so we continue with some examples of OpenGL. First, we need to understand how to draw, what to draw in OpenGL, and here we can see that we can draw points, independent lines. Independent lines means that each line has 2 points and then set of new pair of points or 2 points, they will get a new line. Okay, line loop, it's different than the lines because when you have the first 2 points it will give you a line, but then any next point will be connected to the last point. So for example, this is your first point, then you go to the second point, then any third point will be connected to the previous, and fourth is connected to the third one, fifth one is connected to the fourth one, and so on. And the last point that you draw, it will be connected to the first point. Okay, so that is a line loop. So in the line loop, you start from one point, you end at another point. Between all those points there is a line, and the last line is connected automatically for you between the first and the last one. Similarly there is a line strip. Okay, and in the line strip what you see is that the last and the first points, they are not connected. Okay, it's same like line loop except that it's not a loop and it is a series of points in the form of lines, and the last two, they are not connected for you. Independent triangles, they are like independent lines. Okay, so a set of 3 points will be a different triangle. Then triangle strip is that first 3 points will make one triangle and any new point will be connected to the last 2 points. So here you can see that we start with V0, V1 and V2 for example. Okay, V0, let's say V1, V2, and V3 will be added to V2 and V1, V4 will be added to V3 and V2 and so on. Okay, so in this way every new point will be connected to the last 2 points. Different than that is triangle fan, in which you have 3 points to connect one triangle, but every new point will be connected to the last point and the first point. Okay, so for example, this vertex is connected to the first vertex, which is this one, and the last vertex, which is this one, and any new will be connected to this last one and the first one. So it will be V0 with Vn-1, which is the last one. Okay, so that is a triangle fan. On the same analogy, on the same pattern, we have the independent quads, and the quad strip, okay, and the polygon, which is actually a set of independent points, okay, but they are all connected together in the form of a loop. You need to think about the difference between the polygon and the line loop, okay, how they can be different. So a polygon is a shape which we normally call as the convex shape, okay, and a line loop can be a shape in which there is overlapping between several lines. There is no overlap of lines. Okay, so we will study about convex and concave shape shortly. We know how to set up a window to draw in OpenGL, and today we will use this complete program. So we have the complete program here. I have already discussed that. This is the complete program. We have a draw function, we have an init function, and then we have the main function. Okay, and step by step I explained to you in the last lecture that in the main, okay, which is of course the only main function in a C program, the first line is glut init. So we initialize the glut system, okay, the windowing system that will be responsible for drawing in the current operating system. Then we set the display mode. Here we are talking about the single mode, okay, single buffering. We will also see in the next lecture about double buffering, and we will see the difference between single and double buffering. Then we have glut Rgb mode, so we are specifying the RGB color system. The window size using glut init window size command function. This is 600 by 600, that will be the size of the window. the initial window position, 100, so starting from 0, 0 at the top left, so 100 pixels right and 100 pixels down, and 600 by 600 is the width of the window. So that will be the window size and position. Then the title of the window, and this title, when we execute this create window, it will actually display the window. So before this, nothing will be displayed, and the create window will actually create a window on screen and with this title. The display func, that's an important function. If you miss that, well, any of these you miss, you will be in trouble. But this one is actually tricky because sometimes we forget to change the display function. So display function is the name of the function that will draw actual things on the screen. So what is draw? Draw is actually the name of this function. If it's a different function in which you are drawing, so you should change this draw to the name of the function which will draw on the screen. Okay, so that is specification of draw function. Init is one more type of init. So the first init, initialization, is the fixed function from blood. It will be like this, and it will initialize the system. This function is your own function here, init, okay, in which you do what? You initialize your colors, like what color you want. Clear color means the background color, okay, so the background color 111 means this is pure white background color, and you also specify the type of mode, the mode of 2D or 3D. So we specify the 2D mode, and I will explain with an example that what does this minus 2020, minus 2020 means, what are these coordinate systems. Okay, so this is very important to understand the coordinate system here and the size of the window here. So this is in terms of pixels, this is in terms of OpenGL units, and I will show you the difference between them. The very final thing is GLUT main loop, that I will explain also shortly, but this loop means that you need to process all the events of drawing, all the events of mouse, keyboard, any input event, any graphics events, and you should process them and execute them repeatedly in a loop. Okay, so any type of animation will be done in the loop, or any redrawing will be done in this loop. Okay, finally we will return as usual, because we have integer return. So this is 0 means successful return to the operating system, but this return will never come in normal conditions, because GLUT main loop, it will continue executing forever. Okay, if you stop the main loop, then we can come here, and the reason to stop the main loop, of course, is terminate the program. But how do you stop the loop, we will see. Okay, we will see some examples in which we should understand how to stop a program. Now, in general, you can stop a program by clicking on the cross button of the window. Well, that's the easiest way. But if you don't have a cross button, like this is a full screen, how do you stop? So we should know that. Okay. Now we also know, and studied this before, that GL vertex is a function to draw points on the screen. Okay. So normally every shape that we see here is composed of points. Okay. So even an independent line is composed of points, and so on. But the vertex command itself will just generate the points, and for independent lines you need to specify the endpoints, and the OpenGL system will automatically fill the remaining points between the 2 points using algorithm, either DDA or the Bressenheim or any other variation of the any existing algorithms. So we studied about vertex. What is a vertex? A vertex is a point, and it's different than a normal point, because a point is a coordinate system. In a coordinate system represents just a 2D or 3D space point. Okay, so it can be 2D or 3D. Vertex is same as a point, except that it has more information for the graphic system. For example, the color of the point, the orientation of the points, etc. There can be things that is needed by the graphics package or the OpenGL to render this point in 3D space with certain properties. So a GL vertex is the main function, but it can have some variations. So there are 3 possibilities which are represented by D, T and V. So D means it can be 2D or 3D. So we can have GL vertex 2 or GL vertex 3. So GL vertex 2 means it will take 2 parameters x and y. GL vertex 3 means it will take x, y and z. Okay, so if you give 2D, by default it should take z as 0 automatically. Okay. The second variation is that of type. You have integer, short, float or double. Okay, so you can use I for integers, so that will be GL vertex 2i, or with f you can have 2f or even 3f, 3d, 2d, etc., where d means double. Okay, and finally you have v, which is optional for vector points if you want to use vector points or an array. Okay, so these are some examples. GL vertex in two-dimensional integer. 2i means two-dimensional and integer, and we are passing the x and y coordinates as 5, 5. Okay. The next example is 2f. So still we have two-dimensional, but this time we use float. Okay, so it can take a floating number with decimal integer. Why would we use float? When we will use points as integers, it will be clear with the help of examples. 3i, three-dimensional, x, y and z with integer coordinates. Okay. Finally, 2iv is two-dimensional, integer coordinates, and v means we will give it an array. Okay, that's a vector or an array of points. Okay, so we will see the example how to draw, let's say, 3 points or a triangle using various variations. So here you see 2 code examples on the left side and on the right side. First, let's see the right side. What do? We use GL begin, GL line loop. So you understand what is a line loop. A line loop will create what? Lines in the form of a loop, so that the first and the last point, they are connected. Okay, we have 3 points, so it will have a point at 0, 0, then at 1, 1, and then at 0, 2. But because of line loop, these 3 will be connected. So there will be, let's say, 0, 0, it will go to 1, 1, then it will go to 0, 2. So although there are 2 lines, but it will be connected by the third line between the last point 0, 2 and the first point 0, 0. So it is actually a triangle. Okay, and remember we need to use GL begin and GL end for every type of drawing, and we need to specify what we want to draw. So here we are drawing a line loop, and we will see other possibilities. Okay, so in this example we are seeing 3 points. Okay, we draw those points one by one, or 3 vertices. Now here on the left side we create an array of points. There are 3 points in this array. Point 0 is at position 0, 0, which is of course the first point. Then the second point is 1, 1. Then we have 2, 2 or 0, 2, whatever we want for the third point. Once again you have a line loop, but this time, like in the previous example, we had 3 points. No, we don't call the GL vertex 3 times. We call it only 1 time, but we pass the array A as an option. And when we pass the array A, we will also use the function v. Okay, which means that this will accept an array, and the array will contain points, so it will automatically make a line loop between all those points. Okay, so the result in both cases is the same triangle. Okay, how we can change the colors? We discussed last time that you have 2 possibilities, either using the unsigned byte. In unsigned byte you have 3 Rgb values, but it is in the form of a 1 byte or 8 bits, which has value between 0 to 255 for each one of them. Okay, so red can be from 0 to 255. Similarly, green and blue can have ranges from 0 to 255. Okay, now we cannot use color names here. Okay, or we should not use hexadecimal. One possibility is to use Rgb Triplet. Okay, which means 3 values from 0 to 255. That will be using 3UB function. The other one is the 3F, which is 3 floating point numbers, and the floating point numbers will be ranging between 0 to 1, where 0, 0, 0 means black and 1, 1, 1 means purely white. Okay, so the variation between 0 and 1, you can have different like 255 possibilities. Okay, so 0.001 maybe 0.1 or 0.9, 0.51, 0.52. They are all different variation between 0 and 1. Okay, now before we go and go to the geometric primitives, let me show you. This is very important now because this is your homework, so you should understand that how to run OpenGL code. So we will create a new project and we will have a sample code and we will use that. So let me open Visual Studio. Okay, you should follow these steps for your own. I have already some projects, but let me create a new one. So I will create a new project. This is the first time. Let's say you will do the same thing. Let me create an empty project. You can have a console app, the same thing, but let's start with totally empty project, nothing inside. Okay, and then I will call it, for example, OpenGL, and this is the girls section. Okay, and that is the name of the project, that is the location, and there is a solution. So right now the project and the solution, they are the same. Then we will add more projects to the same solutions and we will see how does it work. Okay, now we will create this. It will just give us a blank solution or blank within that solution. So the solution is OpenGL girls. Within that there is one project which is OpenGL girls. Okay, now I need to add a new item. Okay, I can add existing item, but let me start with a new item. Okay, and that is a C++ file, empty file. I will simply add that, and the name I can call it empty window, for example, empty window setup. Okay, empty window. Now this empty window, in the beginning there is nothing, but I have the code which is the same one in the slide, but I will just copy it from here. And the empty window. Okay, so if I open this code in Notepad++, it's here. I will just copy this and paste it here. Otherwise, I can also use to add an existing file, but this is just to show you that let's say I have typed this code. Okay, and I will explain one thing, that in the slides, the complete window program has something like this, gl/gl-glut.h. Okay, now we have directly glut.h because in the OpenGL setup, I explained to you to put the header file, this glut.h, directly into the include folder of Visual Studio. So we don't need the GL, but if you put that in the GL folder, then you will have gl/glut. Okay, so according to the instructions that I gave to you early, let's use glut.h. And remember, for any example in the slides, if you see gl/glut.h and you see an error, so that means that you need to remove gl/. It will only be about glut.h. Okay, now here I define two functions. Okay, this is declaration of two functions. Why do I declare? Because if I don't use them or define them, actually I don't define them before main, I need to declare them, which means I will be actually defining them after the main function. The same thing as in the slide, I have integer main, glut init. It will initialize the glut library system, then display mode, window size and position, create window, and after that I have the init function. Okay, the init function is the one which I have written down, in which I have two things. One is the clear color and the other one is the GL Ortho 2D. Okay, and we will start with understanding what is GL Ortho 2D in this example, and we will change it to understand exactly how the coordinate system of OpenGL works. So in the init, we are just clearing, we are just defining, because this is about initializing. We define that my clear color is white. 111 means white, 0 stands for alpha, and we are not using alpha, which is the transparency. Just focus on the red, green and blue values, which are all ones. So that is like 255, 255, 255, or full white color. okay, and after that we are specifying the 2D orthographic view, okay, so the view is 2D view, okay. That's about the init, we call it here in the main. After that we use the built-in library function of what, which is the display function. What should be our display function? So the display function is draw, which is here, and in the draw function what I am doing, first I clear the window, okay, GL clear will actually clear everything in the graphics window, then it will set the color. Here I have set the color as red, okay, so whatever I draw here will be in the red color, and then I use GL flash, okay, so GL flash is very important. If I comment it or I forget it by mistake, we will see that we will not see the output in synchronized way. Sometimes it may be shown, sometimes it may not be shown. So it's important that when you finish any drawing activity, you use the GL flash here, okay? I explain, and further it will be clearer in the next few slides what is glut main loop, but this will start the event processing, which means the drawing function and the input, etc. Okay, so what will happen if I run this program? What is it doing? Just creating a window. The size is 400 by 300, and the position, let me make it 150 by 100, and that is OpenGL testing is the first one, okay? That will be the title of the window. So if I run this from debug with F5, I can start debugging. Okay, so what you see here is a simple window. Okay, the initial position was here, so that was about 150. OpenGL testing is the title. 400 by 300 is the window size. I can change the window size to whatever I want. Okay, let me make it bigger. So let me make it, for example, 800 by 600, let's say, and the position remains 150, 150. Okay, let me press F5. Okay, now the window size is bigger, and I move it to this position. So if I want it to be at this position, for example, it must be something like 450. Okay, so next time I run it, it might be coming on this side. Okay, now what else do we have? So we know how to create a window, but there is nothing inside here. The window is totally empty, and we need to add something. Okay, so if you want to go and see our codes, geometric primitives, there are different primitives. The very first one is about points. If I'm going to create points, so I will use GL, begin with GL points, and then I will specify the vertices. And we need to understand how do they work. Okay, the coordinate system, how does it work? So the point, you can do it, it's easy. Let me move to a complex one, which is drawing lines. Okay, for that I will use GL lines. Okay, and even further we can use the line strip or the line loop. Okay, so let me start with the line loop, and then I will go back. Okay. Remember that the draw function is as it is. Let me have a new function and let me define it above, so that I don't need to declare that. So I can say void draw lines. Okay, and it's not taking anything, and I will just call it void draw lines. Now the very first thing is I need to clear the screen. Okay, so this is GL clear, and GL clear, if you see what it's taking GL color buffer width. Let me copy this. Okay, I can just have autocomplete, but it will have GL color. Okay, and after clearing the screen, I need to draw lines which will begin with GL begin. Okay, sorry, and in GL begin I have GL underscore line underscore loop. That's what we used it. GL underscore line loop, there is a semicolon, and then I need to create, let's say, 3 points. Okay, so I can have GL vertex Okay, I want two integers for x, y, and z. Okay, and then I need to specify the integer. So let's start with the center. Okay, that's my first point. Then I move to GL vertex 2i. Let me have it, for example, 10, 10 as a point, and then the third one is GL vertex 2i, and let me make it, for example, the x-axis is the same as 0, and the y is, for example, 10. Okay, can you think of this? There are three lines. Well, actually there are 3 points, but the first point will be connected to the second one, 0, 0 with 10, 10. Then the 10, 10 will be connected to 0, 10, second line. And because it's a line loop, so the OpenGL will connect 0, 10 with 0, 0 as the last option. Okay, so let's finish this. GL begin and GL ends. Okay, GL ends. So that will do something. Now, I'm not using, there are 2 things I need to adjust. First, I will use GL flush. I need to use GL flush before finalizing. And the second thing is I need to specify the draw function. Okay, what is my drawing function? So the draw function now should not be draw because I want to use this. So I am going to use the draw triangle. Okay, so the draw triangle is draw lines, okay, which I defined above. So this is my draw lines. It will draw 3 lines as a line loop, and we should see this function now. This function will not be used. I just keep it, maybe I need it later, okay. So if you want even another function, you will define that will become your drawing function, okay. So I have changed my drawing lines, but if I start debugging, okay, I don't see anything. Okay, and I explained to you the reason is that I have not flushed my output. I need to flush my output. So after GL end, I need to have GL flush. Okay, so flush means to display the output immediately on the screen, and okay, still it's not there. Okay, that's strange. So we need to see why is it not there. Okay, that's I will explain, and it's the reason that what is my display system. Okay, what are my display coordinates? Now I have specified my display coordinates at -20, 20, -20, 20, and here I will see that I have a line, 3 lines from 0, 0, 10, 10, and 0, 10, and then I have GL end, and then GL flush, and here I have used draw lines. Okay, so I don't see any reason except that maybe it's because of the color. Okay, because my clear color is white and the default color is also white, so I need to define, let's say here, the red color, so I will have my red color here. Okay, so it can be anywhere because it's just a specification. So GL color, okay, and I can use 3B or 3F. Let me use 3F, for example. Okay, and I will use 1.0, 0.0 and 0.0. So that's red color. Okay, GL color 3F. Just we specified it before in the draw. Now I specify it in the draw lines. Okay, so let me run that once again. Okay, now you see. So before the draw color was white, the background was white, so we could not see that. Now I have changed my color, and we can see that this is the a triangle. We need to understand the coordinate system now. Okay, what I have specified is ortho 2D with -20, 20, -20, 20, which simply means that the first -20 is x minimum. So this side is -20, the x max is 20 on this side, y minimum is -20 this side, and y max is 20 plus 20 this side. So this is actually a square with coordinates of minus 20. So total, it means that from minus 20 we'll start, we'll reach 0 here, and then from 0 we'll start at 20 here. So there are 40 points in OpenGL coordinate system. The size in terms of pixels is what? It's 800 by 600. So 800 pixels wide and 600 pixels tall. That's in terms of pixels. But in OpenGL, we don't talk about pixels. We have OpenGL coordinates, and we define it here. So we have defined this in terms of 40 points wide and 40 points tall. Now I can change this. I don't change the triangle. Okay, I will just change this to minus 10, 10, minus 10 and 10. So what will happen? What do you think? Before this is minus 20, now it becomes minus 10. And this side before was 20, now it becomes 10. What will happen to this triangle? Think about that. Any idea? What will happen to this triangle? Will it remain the same or not? Because we are not changing the size of the position of the triangle. The triangle has the same 0, 0, 10, 10 and 0, 10. We have just changed the orthographic camera, the coordinates, and it has become now between minus 10, 10 and minus 10, 10. So think about this position, and let me run the program again, and we will see what are the new positions. So okay, now here you see. What you see here is that this is 0, 0. This is x is 10, y is 0. And this here is my point 10, 10. Both x and y are 10, 10. And this is 0, 10. But the line is just on the edge, so we don't see the line from 0, 10 to 10, 10. Okay? So this is the same thing, but we don't see it because it's on the edge. If I just make it 9, so remember that if I change this to 9, it will be not 1 pixels. Okay, from here to here, there are 300 pixels. Okay, so it means that one point in OpenGL is 300 divided by 9, which is about 33, for example. So changing from 10 to 9, it will move around 33 pixels. Let's try that, and we see how it works. So I will make this, instead of 10, 10, I will use the unit 9, because 10 is the size of my, you can call it canvas. Okay, now you see previously it was like 10 was here, and you could not see that. Now I made it 9, so these many pixels, which are about 33 pixels, almost 30 pixels, it is now reduced this shape. Okay. Now this clarifies the coordinate system. If I don't give any coordinate, or let me make it smaller, let me make it 1, 1, what will happen? Because I want to clarify 1 point, let me make it 1, 1. So this is a very small. So this is exactly how 1 unit is now. Okay, so total is 10 from left to 0, and then from this 0 to right, these are 20 points. Out of this is only 1 point. Okay, not point, in the coordinate unit, actually 1 unit. Okay, so 1 unit right, 1 unit down, and then there is the line which joins these two. Okay, now 1, 1, remember. Okay, out of 10, 10. I don't change this code. What I do is I will just remove this. Okay, and we want to see what will happen. I don't specify anything. And now if I run this, the ortho 2D, it is again just like 10, 10. Okay, although my size is 1, 1. So what do you understand now? The size is 1, 1, which means from this 0, 0 to here, this is 1. Okay, from this 0, 0 to the right side, this is again 1 unit. This is 1 unit, that will be negative 1, and here down that will be negative 1. So it is automatically, when you don't specify, OpenGL uses the 1 by 1 or 2 by 2 actually. Okay, minus 1 to 1, which is 2 units, and minus 1 to 1 in the y-axis as well. So this is 2 by 2 unit square, okay, from minus 1 to 1 in both axes, okay. If I make it 0.5, 0.5, my triangle, let me make it minus 1, 1, it is like this. We don't change that, the coordinate system, but I change the size of triangle to 0.5, okay. So here I make it 0.5, this will be 0.5, and that is also 0.5, okay. So from 0, 0, 0, which is the center, I will go to 0.5, 0.5 on the right side, so 0.5 here, 0.5 up, so it will be here, and then on this side is 0.5, 0.5, so the triangle will be like this, okay. So let's run that. Okay, what's the problem? I don't know. Did we make any mistake? 0, 0, 0.5, I don't know. There is flush. We have the flush, yeah. Okay, 0, 0, 0.5 and 0, 0.5, okay. Okay, let's see what's the problem. Let me revert back. Oh, sorry, yeah, okay. Now the thing is, because you see, I used I, okay. I was going to explain this point, and that's good, it came. So with I, this is converted into integer, so that will become 0, this will become 0. So we need floating points. So it's better, or rather it will work only if I convert this to float, and for compatibility, let's say we have all the same points, so that will be 2f, okay. So when I run this, yeah, okay. So remember about these changes, okay, 2i versus 2f, okay. Now if you are thinking that how can we have, let's say on the negative side, we have just been talking about positive side, what about making these negative, okay, let's try that. And it will be, for example, minus 0.5, minus 0.5, minus 0.5, and even this, let's say I make it minus 0.4, okay, just to have a different opinion. Okay, well, it changed quite significantly, but these are the points, okay. So 0, 0 is the center, minus 0.5 is this one, and minus 0.4 is this one, minus 0.5 is this one, and we got a different triangle, okay. Let's now you know that with negative and positive we can move it anywhere to any position by changing these. That's easy to visualize, but understanding this ortho 2D is something. What about this option? When we have from 0, 0, 200 and 0, 150, what does that mean? Think about that, okay. So if I make the minimum of x, which is this point on the left side, that will be my 0, so this will become my 0 on the left side. The maximum on x, that will be 200, okay. The minimum of y will be 0, and the maximum of y will be 150, okay. Now let me make it same first, and then we will change it, okay. Now if it is between 0 and 200, so there 1, 1 or 0.5 will not be able to, we will not be able to visualize. So the 0, 0 will start from here, and 200, 200 will be this point. So it's actually a single, in the first quadrant, it will be starting from 0, 0. So now if I draw something like 100, let's say 100 and 100, okay. So 100, 100 is actually this point, okay. Then I want to move to this point, let's say that x will be 150, y will be 100, okay. So let me make it 150 and y to be 100, okay, which is this point. And now I want to move to this point where x will be 0 and y will be 150, okay. So that is 0, x will be, because it's 100 is the center, okay. This point here we have 0, 0, 100 and 100 is this point, okay. And we want here, So x is 100, y is 150. That is 100 and 150. Okay. So close this. Start this. And you can see we have a triangle. Now think about the effect of changing, this, the ortho 2D, 2D orthographic coordinates. This is a very powerful mechanism in controlling. Like in this case, if we do anything negative, the triangle will be outside the bounds. Negative means either here or down here. Okay, and what will happen if it is even more than 200? Okay, we will not see that. So here x is 100. Okay, if I move this to 200, it will come here. If I move it to 210, it will come outside the window. Okay, so the very first coordinates, let me move it to 210. Okay, and just see how does it change my drawing. Okay, so actually 10 pixels outside, this is how it changed my drawing. Similarly, if I move this out here, okay, so I will see partial line. Let me move the coordinate, which is 100, 150. So this 150, I make it 250. Okay, the y-axis will be higher, so that one point will be above, and you can see that it is cut. So that is actually clipping. Okay, a topic in which we study that how to clip the points which are outside and how to keep those which are clip the points inside. Okay, so apparently they are different lines, but actually we know that these are three points, but 2 points are outside. On the negative, it's the same thing. Okay, it's outside the drawing area of the canvas, and you would not be able to see that. Okay, now let me ask a simple question. We move to from a line. We use the same line loop, but let's move to 4 points. Okay, and I want you to tell me if I want a rectangle from here to here, here and here. Okay, so at this center, it has the center of the square. Let me make it a square, not a rectangle, but a square. Okay, because we are evenly spaced, and we will see how does the spacing change after this rectangle thing when we draw it. So the center will be here. One point is located in the middle of this quadrant, then another one here, third point here, the fourth point here. Okay, and I know the coordinates of my orthographic 2D. So what do you think, what do you suggest will be the coordinates of a square with points spread in these 4 locations in the center? So what will that be if my center is 100, 100? Yes, any idea? This is 100, 100. Okay, then this point will be actually 50, 50. This point will be 150 and 50. This point will be 150, 150. And this point will be what? It will be 50, 150. Think about that. Okay, let me write it and then you can think further. So my first point, as I said, it will be 50 and 50. Okay, then we go to right, so y remains the same, but it x total, if I see x total here is 200 and this is 100, so I want it to be here, it will be 150x and 50y. Now I will increase the y to 150, 150, the third point, 150, 150, and I will have another one, GL. Now remember, I'm using to f with integers, which is totally fine. Okay, it's not a problem. So that will be 50 and 150. Okay, and just for the sake of understanding, I can change this red to green. Okay, so that will be in the green color. So let's see that. If I have this, I will close this. Let me run it once again. Okay, so this is what I wanted, and well, it's not a square, it's a rectangle, although here we see that it's from 0 to 200, 0 to 200. Why is that? The reason is our number of pixels, the size of the window. The size of the window is actually rectangular. Okay, so this 800 in this direction, so that is about 20% more in the width. Let me make it same. So if I make it both 800 by 800, we will have a perfect square. Okay, so you can see that's a perfect square. So now I have a square window. Okay, within the square window I have a perfect square. So we know the effect of changing pixels. What we learn is changing pixels and changing the coordinate system. Okay, one more point remains. What happens if I make the x from 0 to 100, let's say? Okay. If I make it, let's say, to 400, make it double. What will happen? I don't change the number of pixels. The number of pixels in this window remain 800 from left to right and 800 from top to down, which I define as window size, the number of pixels. But in the coordinate system, my x will become 400, and these coordinates remain the same: 50, 50, okay, 150, 50, 150, 150, and 50, 150. These are the four coordinates. Okay, so what do I do? And green color, it doesn't look very nice, so let me change that to blue color. Okay, for the next time. Okay, now with the new coordinate system, what do you think? So x is now 400. So these points will be readjusted. Okay, this is 50, 150. So the height remains the same, which means the new figure will have the same point line. The horizontal lines, they will remain at the same height, but the position of the vertical lines will change because of the x. So what do you think will happen? Because now it's 200, we are dividing it, we are multiplying it by 2, so there are more pixels. So actually these points will move to like here and here. Why? Think about that. Okay, let's see. Yeah. Okay, so the color has changed to blue, and although my triangle, my square, which was a square before, okay, it was a perfect square with these coordinates, it has become a rectangle. And the reason is I have squeezed this x-axis, okay, by stuffing more pixels. Okay, the coordinate system is increased, so it means that now my point, one point on y-axis has the same length as, you know, 2 points on the x-axis. Okay, it is double now. So double means we are making it half in terms of number of pixels. You know, the area covered by the same number of pixels. So it's a logical thing. Think about that. If I make it 100, what will happen? Okay, if I make it 100, the problem will be because I'm using 150, so I will not see the complete picture. Because on the x-axis I go to 150, so it goes out. Okay, so on x-axis I have from 0 to 100, so this is 0, this side is 100, so my 50 is here in the middle. This point is 50 on x-axis, okay, which is my first thing. X-axis 50, and the last point is also 50, which is totally fine. Okay, but 150 will go outside in this area, so it will be like this. Okay, so this is new learning, and you should understand how does it work. If I make it 100 again, but I need to make this within the region. Okay, so if it's 100, 100, So let me make it everything 50-50, so that will be exactly in the center. Okay, I come back to drawing the same shape just like before. Okay, but why? Because all of them 50, 50, 50, 50. What did I do? 100, 0, 100, 0, 100, and this is okay. Is it because of 2f? Okay, let me make it 0. I'm not sure. No, it should not be like this. Red, green, and blue. Let us see. Okay, what happened here? Let's debug that. Okay, where is the problem? 0, 100, and 0, 100, and 50, 50. Oh, sorry, yeah, I made a mistake. Okay, so 50, 50 means a single point. Yeah, so everything will be just a single point, and we only could see, let's see, the single point. It's very small. Okay, I don't see the single point, but there is just a single point. Now the point is very small. We can have one more thing, that's a learning, that it will be GL point size. Okay, and GL point size, let's take 5 pixels. 5 points means it's 5 pixels, and let's run that. So we will see 4. Okay, still we don't see that for whatever reasons, but shortly I will explain when we move this to a different point. Okay, so that is 50-50. Okay, that's in the center. No, that's not good. Let's make it 25. It will be, because it is 25. Okay, on the x-axis it remains 25. No, it goes to 75. It remains 75. And the third point is it goes to top, which means it will be 75 and 75. Okay, and then it will be 25 and 75. Think about that. Am I right or wrong? 25 and 75. Okay, and let's run that. Okay. Okay, now the point size is not working. Yeah, I understand now. This is another reason. Because it's not about points. We are using line width. Okay, so it should be another function which is GL line width. Okay, so GL line width 5.0. That will make the width of the line, and I will see also the point size, the effect of point size. Sorry, it's here. That. So now the line width is, see, 5 points, and the point, why it doesn't work? Because I have not used a single point. So if I want to see the point size, this is another exercise which is GL begin, and that is GL underscore points. Okay, and no points, it's GL underscore points, and I will just have 2 points, let's say GL vertex and 2i. So let me make it in the center, that is 50 and 50. That's 1 point, and GL vertex 2i. Another point is, let's say 60, 60, and I will just GL end this. Okay. Okay. So that's about the point size. That's one thing. And let me also change the color. Here it is blue for these 2 points. So for this point, let me make the color should be. I can use UV, you know, the color to be UV, unsigned light. And what was that? I can, let's say I want to have a gray color, light gray. So that is 200, 200, 200. That's light gray color. I'm not using the F version, the UV version, unsigned light. Okay, and that will have a line width of 5 and a point size of 5 as well. Okay, okay, I still don't see the points, which is strange for me. Maybe I'm missing something. see further and try to explain this. Okay, one more thing. What happens if I have a different point color here, and after 2 pixels I have a different color? No, okay, sorry. What did I do? Yeah, I have different color here, and after 2 pixels I have a different color, and let me make it 100, 50, 0. Okay, red and green, slightly red and green, they will be combined. So what will happen to the remaining 2 points? Okay, now this is the first point. The second point, they are on the same color, and when it moves from this point to this point, it changes the color. And from this point to this point, it's the same color. There is no variation here. There is no variation, but changing from the gray color to slightly brown color, it's changing here. Similarly here, and that's how you apply different shapes to line, and that's the importance of a vertex. Okay, because you have changed the point. You have not changed the point, but the color has changed for each point of this line, and that is the importance of a vertex, which represents the color alongside the point, coordinate in this space. Okay, I can now, it means that I can even change for each one. Okay, so let me have first point in one color, then another point, and this time let me make it 200 and 50 and 150, a random one. Okay, and for the last point I will also change it, so it may be, for example, 255, so that is totally right. Okay, 100, and let's say 150. Okay, so I have 4 points, and for each point I have a different color. Okay, for this one, yeah. Okay, so first I have a color, then a vertex, then another color vertex, another color vertex, fourth color, and change of vertex. Okay, so let me run that, and you can see that from one vertex to another it changes the color. Okay, so that is quite good. Now I can do one more thing. This is a line loop. Okay, a line loop has 4 points. What about GL polygon? Okay, we saw that, but we will go back to slide and see this. GL polygon. Okay, so we created now a polygon, and this polygon is filled. It's the same 4 points. Instead of line, we use polygon, so that is a fill. Okay, so polygon, we learned how to have a polygon. There is one more thing, which is GL path. Okay, GL path. It also has 4 points. Okay, do you see any difference between them in terms of colors? Think about that. Okay, one more thing I forgot to see or tell you is the importance of, you see, if I make it back polygon and run it. Okay, now I have these 4 points. What happens if I change the order of these points? Okay, let me change the order of these points. So this is the first, then let me move this. I will remove this. This is my second point, and the second point becomes my third point. Okay, and it's like this. Let's run this. Okay, what happened? See this effect. I'm listening to you. This is my first point. The original one came here. If I make it the last one, what will happen? So, what do you see? Actually, the order matters. Now, how does this one work? Let's see. My first point is 25, 25, which is this one. After that, I go to 75, 75, which is this point. Then I go to 25, 75, which is this point. And then I go to 75, 25 on the last line, which is this point. Okay. Now you can see it becomes like two triangles on top of one another. So the bottom triangle is this one. Okay, that's behind this triangle. Okay, so if I remove the last point, okay, I will see only the bottom triangle. Okay, which means this one, the fourth point. If I just comment it and see, remember this figure. So this point will be removed. This will be removed. You will see only the back color. Okay. Yeah. This is how it works in terms of shapes. So we have learned about polygon. Same would be see what happens for quads. Let's say we do the same for quads. Okay, we have random points not in any order. So quads. Okay. Okay. One thing I didn't tell you, what will happen about the quads if I have only 3 lines? Quad means 4. If I have only 3 points, what do we see? Well, we don't see anything. And the reason is because a quad needs 4 points. Okay? So let's make the original quad. The first point on the lower left is 25, 25. The next point, x goes to 75, y remains 25, so it will be this point. That will be the second one. Okay, I will uncomment that. That's the second point. The third point, it goes up into 75, 75, and the final point is 25, 75, so that gives me a quad of 4 points. Okay, now I add one more point. Okay, just let's say it's the same color and somewhere random. It is, for example, x remains, x is 15 and y is 60. What will happen to that? Do we see any change? Let me run that. So, if we run that, we don't see any change. And we will not see any change if we add even 2 more points. The reason is, for any quad, we will need how many points? 4 points. So the first 4 points, it will create a quad. If it's less than 4, it will not create anything. Then if you want to create a new quad, it will need 4 more points. So if you add 3 points, even, there will be no effect. We need to have 4 points. Okay? Similarly, for the case of lines, if I make independent lines, instead of saying GL quads, if I say GL lines, okay, what do we see? Let me stop it and run to see, and then I will explain to you the output. There are 2 lines. The first line is between these 2 points, 25, 25 and 75, 25. So that is one line. The second line starts from 75, 75. It goes until 25, 75. That is second line because it needs 2 points. Now this will not have any effect because it's a single point. If I want to make a line of it, so let me add this to it from 1560. So 1560, x is 15, almost here, 60 is almost here, and then let's say I want to move to somewhere here. Okay, so that means I will move x to, let's say, 85 and 60. Why 60 is somewhere here? No, it's not 60. Let me make it 30, and that means 70. So that will create a third line, which will have same color. Okay, which is the last color we used here. So that was the last point before, and now I have a new line which is the same color because we don't change the color. So for lines, it will work in terms of pair of points. Okay, if you have, let's say, 100 points here, that will be 50 lines. If you have 95, that will be 50. That will be 49 lines because it needs polygon, but it will be just a point and it will not draw a point. We learned. Okay. Now, what else do we have in the shapes? Then we will stop. We have drawing primitives. So these are the primitives. GL points for drawing pixels. Okay, we couldn't. I remember this. Okay, let me delete all of them. GL line, width, GL clear, GL end. Okay. And see what was the problem here. GL point size. We begin GL points. Okay. And we had 50, 50, 60, 60. And if I run this. Okay. Well. But why did the background change to white? Because actually I did what? I didn't do one thing. What did I not do? I also removed the code for clear actually. Because I did not clear, so the background became black. So let me say GL clear. Okay, and this was clear buffer width. Okay, which was before here. You see GL color buffer width. Okay, color underscore buffer width. Okay. Okay, and after clearing, it will use the background color of white. Okay, now we can see the blue pixels. Okay, why it didn't work before? I'm not sure. Maybe we need to have a flush before drawing anything else. I'm not clear about that. We need to check that. But at random position 50, 50 is the center and 60, 60 is here. Okay, that's an example. Let me have one more example. Okay, which is about random lines. Okay, so I have a code. Random points, yeah, random points. I have two random points. So let me create an empty project new because I want to have a new thing. So I will add a new project here. I will have add a new project, and its name will be it's an empty project. Okay, its name is random points. Okay, it's in the same space solution. Okay, and I will add the source file. I will add an existing one this time, and it's where it's at this location, and it's random points. Okay, so now I have. Let me close this one so that it's off the screen. So this is random points. Okay, remember that there is no GL, and we use free blood. Is not here. That's what we this program was originally for Linux, so I use FreeGlut, but here we have the glut, just the glut, and when we use glut, it should remove all the errors. Okay, yes. So for Linux, actually, I had the free glut. Now for Windows, I have the glut. Okay, and the stdlib and stdio, I'm not sure we need them. Just see if we're using them or not. Yeah, random function. So random function is in stdlib, I believe. Okay, and stdio, I don't need it. Okay, so let me remove the stdio because I'm not taking any input output. Let me run this and then we will see what's the output. Let's see the output first. Oh, what happened? It's the same old output. Why? Because I'm running the same program. And the reason is I created a new project, but this one is the default one. You see, this is bold, this is not bold. So I need to change this to the new project. So that will be my set as start project. I will start from here. Okay, now this is my default project, and I will load the debugger. Okay, no, there are errors. Wait, exit function. Okay, yeah. So the exit is, where is exit function? No. Exit redefinition, no return results. Where is exit redefinition? Okay. stdlib. problem. Magic dots, GL end, GL main loop, it's integer. Okay, so this, as you can see, the same thing. We first initialize the clutch system, then display mode is single, the window size, the window position we don't set. So if you don't set, it may be 0, 0, I think. Okay, the create window, the clear color, the background is white. We clear first here, and the display function we call it magic dot. Then the idle function is idle. So where is the idle function? Where is the display function? Okay, we can see both of these functions, and I will explain it to you once I am clear that what's the problem, where's the problem. Let's see. Okay, no return difference exits. Okay, Ph.D live. Okay, so this is random. So it's redefinition of exit, I think. Okay, maybe I need to put it up. Sometimes it is a problem. Okay. Yeah. Okay. Now what you see is very quickly random points are generated with random colors. Okay. Random points and random color, and it's going to fill the screen. And as I said, the start position is 0, 0 almost. Okay. The window position. When I don't specify, this is the window position. So these are random points at random position with random color. Okay, let's try to understand this. First, as I explained, the main is same. There are two things that are different. One is that display function is now magic dots, and there is an idle function as well. Okay, so when is the idle function used? We will study that in the slides, but right now focus on the display function. It is magic dots. Okay, the idle function is also executed, but in the slides the text is there, so I will read it from there. Magic dots is my main function, and in magic dots I have the matrix mode of GL projection. So we want the projection matrix. Okay, I have load identity. Actually, we don't need them here. Okay, so ignore them for the time being. My GLU ortho 2D, again, I don't need it to be here. It should be in the init, in the initialization. Okay, I don't need to set it every time. This is once, and let me make it where? Let me make it here after GL clear color. I think we can make it here. I hope there is no problem. Yeah, okay, and let's try to see this. Okay, so it's working fine. I removed it because I want to focus on the magic dot. What is this doing? It's calling the color 3F. It's setting the color, and the color is RGB. And RGB, we calculate this as random colors here. Okay, how do we calculate that? X and Y, they are random position between 640 and 480. 640 and 480, this is the size. Now normally we should use variables for that instead of, you see, having this as constants. And in order to have one coordinate or point in the OpenGL the same as 1 pixel, so I make it same as 640 by 480 in the ortho 2D. So it means that in the window, when I run it, in the window, this is my 0, 0, and this is my 640 by 480, okay, and the total number of pixels is also 640 by 480, okay. So every random point will be 1 pixel. That is exactly 1 pixel is 1 coordinate, okay. For this example, this is also we learned that we can have one coordinate system equal to 1 pixel on the screen. Okay, so here I get change the color randomly to RGB. How do I get different R, G, and B? How do they work? So this gives me a random number, Okay, and now exactly I'm not sure if the rand function returns between 1000 or what, but when we make it %480, so it is 0 between 0 and 480. This will be a random point between 0 and 640, whatever the random number is generating, but it will be between 0 and 640. This will be between 0 and 480. This will be from 0 to 8, okay, less than 9, 8.999, let's say, divide by 8. So it means that it will give us a random numbers between 0 and 1. So R will be random between 0 and 1. This will be random between 0 and 1. This will be a random between 0 and 1. Okay, so this will give a random color. Now instead of this, if I want to set it as GL color 3F as, for example, somewhere between 0.5, 0.5 and 0.5, that will be between black and white, a pure gray color, okay, not phantom, but a pure gray color, and this time the screen will become pure gray after some time. Okay, so it will be like a gray color when there are so many points and random positions, so that will be a gray screen. Okay, it's not random color now. So how does it work now? We need to understand this, okay, that there is no loop, you don't see any loop, and that's the beauty of actually the let main loop. Okay, let main loop is doing what? It's repeating this thing again and again. The magic dot is called repeatedly, and all we are doing is setting a color, and we are drawing only one point, so GL points, and then there is one random point, okay, at xy, because xy is a random position, and at that random position and a random color, not random, but the color is this one, so it will have a gray color. So this is repeated again and again thanks to the GL main loop, which we are going to study in the next, or should I say, it's coming now. Just give me a minute. It's not here. It's in these slides. Okay. So the glut main loop, it will come, inshallah, in the next lecture. I will explain that how does it get repeated. We will also study the event processing system of OpenGL. Do you have any question? Any comments?